Hello guys, today I'm just going through a simple circuit that can help you protect inputs of a microcontroller or your system from power surges. In this video, I will go through building a practical example of the circuit that we discussed in the Art of Electronics exercise 1.22. Unfortunately, I did lose some of my footage, so I won't be able to show you the three circuits that I had set up. One of the circuits was using two diodes, going from the input signal to plus and minus 5 volt rail, and the other one was using a Zener diode and a PN diode going to the positive 5 volt rail. The circuit I am going to be able to show you today is just a single Zener diode that clamps the input voltage to plus 5.6 volts and negative 0.7 volts, which I think is the ideal solution for most applications anyway. So first of all, let's put our power supply and the components down that we need for this. So as I said, I'm going to build this with a Zener diode. So let's imagine V1 is a input button or a power supply coming to our system, and the R2 resistor in this case would represent a microcontroller or a other circuitry such as op amps or something. Now let's imagine the circuit that we have operates at a normal voltage of 5 volts and can handle a absolute maximum voltage of 10 volts. So obviously what we want to do is try and limit the input voltage to that component to less than 10 volts. So I'm going to pick out a Zener diode that has a breakdown voltage of less than 10 volts. So you can see there are many options, but in this case I think I will go with a 6.1. So now let's see, we have our Zener diode in parallel with our circuit, and let's set a input voltage. So I'm going to make this a sine wave from 0 to with a 0 volt offset and a 10 volt amplitude with a frequency of 10 hertz. So obviously you'll have 10 volts over here. This Zener diode is 6.1 volts, so should clamp the voltage over here to around 6.1 volts. This highly depends on the current that's going through the Zener diode. And we want to limit the current or the voltage that appears on our R2 to less than 10 volts. So let's simulate this and see what happens. So you can see now, after doing the simulation, that the clamping voltage is roughly 7.5 volts on the positive side and 3.2 volts on the negative side. However, if you look at the current that's going through this circuit, you can see that we have very high current when the Zener diode is clamping the voltage, as the series resistance in this case is very low. So what you would want to do is have a relatively high series resistance here to limit the current that goes through this Zener diode. Obviously, what you would want to make sure is that the power rating on the resistor is such that it can handle the voltage drop and the current that will go through it. Now let's build this circuit up in real life to see what happens. So I'm going to be using a Zener diode in the physical circuit I build. I would recommend using a TVS diode, which are fast acting and have a low capacitance. As the signal generator that I'm using is not able to provide the minimum of plus and minus 5 volts that I need to test the input protection circuit, I will be amplifying the circuit using a non-inverting amplifier with a gain of 5.7. So the circuit I'm using for the amplifier is shown now on the screen. So you can see I've got a 47k feedback resistor and I've got 10k resistor that's going in series with it. The input coming in from my picoscope can give a maximum of 2 volts peak, and I'm able to get the dual power supply from a power supply that I have available. So let's build up the circuit that we saw on the simulation now. Unfortunately, I don't have a high voltage signal source. So what I'm going to do is basically create an operational amplifier and amplify the input signal coming from the low voltage source that I do have. So I'm using a UA741 to create the amplifier circuit, and you can see the pinout on screen now. So I need to connect the inverting input to ground, and basically I have a output connected to the inverting input, and to do that I'm going to use some jumpers. The non-inverting input is over here. That's where I'll plug in my low level voltage source. Now you can see the output is connected. So I'm going to take the output and make it more accessible by connecting it to this line over here. And then what I'm going to do is connect the power rails. So I want to create a negative and a positive signal. So I'm going to use 2 power rails. So I'm going to have minus 15 volts on here and positive 15 volts on this line over here. The ground will connect to the minus 15 line, which is on pin 4. And our input signal will connect to the non-inverting input, which is on pin 3. So now you can see we've got most of the connections done. There's one connection still to make, and that is the positive rail, and that goes to pin 7. So let's test this portion of the board now to make sure it's all working okay. That reminds me, I need to also connect the ground rail. So I've got the ground components reference to this rail here. So I'm going to put the ground on this node. So I've got my power rails connected. So this is the minus 15 volt line, which you can see is just going off the scale here. So I've got my minus 15 line over there. I've got my positive 15 line, which is over there. And I should have an input signal of plus and minus 2 volts. So you can see the time base is a little bit wrong, but we can sort that. So we have a 50 Hertz 2 volt peak to peak signal, 4 volt peak to peak, 2 volt peak signal. And finally, you can see that the output is being amplified to 11.2 volts. So we've got our input voltage working correctly, we've got our power rails, and we've got our output voltage. So I'm going to use a 1K resistor to make sure that I'm not passing too much current through these Zener diodes. Otherwise, I don't think they are rated for very high voltage, high power dissipation, and they may fail. And now I'm going to add a 5 volt rail to simulate a power supply on this line over here. And ground that on the other end. I've modified the circuit slightly. I didn't need the extra diode because I'm using Zener diodes on this circuit here. So this is a 5.1 Zener diode, which should clamp the circuit to 5.1 volts and minus 0.1 volts. So just making sure that the circuit is working properly. Let's check our input voltage again. So we've got 2 volts peak to peak. And our output voltage from the op amp is almost 12 volts peak, and the voltage that would be going to a microcontroller is now clamped at
5.1 volts and 0.86 volts. So you can see that the microcontroller will not see the high voltages and will prevent damage to the microcontroller pins. Thank you for watching. I'll see you next time.